Transverse waves. Before we can understand transverse waves, we first have to understand a wave. So a wave is a continuous disturbance through a medium. So if we continuously disturb a medium, what is going to happen is that we are going to have a wave. So remember, in the previous video, when we had a rope and we only do a single disturbance, we had what we call a pulse. But now if we do many disturbances, that means continuous disturbances, we are going to have a wave. So now this rope, instead of just making one pulse, it is going to form what we call a wave. And a wave is something that goes up and down up until it gets complete. So this first part here is a pulse, and the bottom part here is a wave. So do you see now, a wave consists of two pulses. But now this pulse is a positive pulse and this is a negative pulse. So that's the difference between a pulse and a wave. So now, when we talk about a transverse wave, we are talking about wave whereby the particles of the material will be moving up and down as the wave is moving to the right. So this means what? The direction of the particles is perpendicular to the direction of the wave. And that is what we call a transverse wave. So if we have a wave, we have different things that we need to know. For example, if we have one pulse and the other pulse joining together, that is one complete wave. So one complete wave will just form a whole circle. This is half of a circle joining with another half of a circle. It will make a complete wave, which makes it a circle. So sometimes we can have a wave that starts from the top, move down, and gets up again to the top. So this will also be a complete wave, since it has what? Half of the circle, and then now we have a quarter and a quarter. When we join them together, this is going to form a complete circle. So once we have a complete circle, therefore we have a complete wave. But now that is one wave. So now, if we have a wave, we need to know a few things that makes a wave. So let's say we have now these particular waves. If I can ask you, how many waves do we have? So remember, a wave is when a circle is completed. So now, as we move from the starting point, we're going to make a half of a circle when we get here. And then when we move from there, we're going to make another half of a circle. So now, half of a circle plus a half of a circle, this means we have a one complete wave here. And then we also have another one complete wave. So in this case, we have what? We have two waves. So this point where we start here at 0, this is the equilibrium line. It's the line whereby we just had the rope there before we start to disturb. So that is called a 0 line. Okay, so the length from the 0 line to the peak of the wave, it is called an amplitude. So an amplitude can be the length from the peak up, and then also from the 0 line to the peak bottom. So that will be what? That will be an amplitude. So also, even if we have from the 0 line to the peak at the bottom, this is still an amplitude. So an amplitude is just the distance from the 0 line to the maximum, or from the 0 line to the minimum. The maximum point on the wave, it is what we call crest. So if we have a maximum point, the name of that maximum point is called a crest. So this is a crest here, and that is a crest there. But now the minimum point of the wave, we call them trough. So the word trough refers to the minimum point of the wave. So if one person asks you, what is the wavelength of a wave? So we know that a wave can only be completed if we have a circle. So that means a wavelength is going to be a distance from where the wave starts up until where it finishes. That will be the wavelength. And then now the wavelength is denoted by this symbol here, which represents the wavelength. But now the wavelength is just the distance from the starting of the wave to the finishing of the wave. But now we talk about one wave. So the wavelength will be a distance from here to there. And then the wavelength will be the same throughout. That means now also the distance from here to there will be the same as this wavelength here, because that will make the wavelength of another wave, which is the second wave that we have. So the wavelength is the same throughout the entire waves. And the second thing that we need to know also, the time that it takes to complete one wave, it is called a period. So a period is just a time from the starting of one wave to the finishing of one wave. And that is called a period. So let's say now, if we say now, okay, to complete these two waves, we start at 0 seconds and then we finish at 2 seconds. So now what will be the period of these waves? So this will mean now it took 1 second to complete the first wave, since when we complete two waves, we have 2 seconds. So therefore, the period is only the time it takes to complete one wave, which means 1 second. So the period of these particular waves is going to be 1 second. So now the very same will happen if the total length of the wave here, it was supposed to be 4 meters. So if they ask us, what is the wavelength of the wave? So remember, when they talk about the wavelength, they are referring to the length of one wave. So to complete one wave here, the length will have to be how much? Will have to be 2 meters, since we have two waves and the total length is 4 meters. So we are going to say now the wavelength is going to be 2 meters. So you need to be able to know how to identify the wavelength and the period in your wave. It will be very much easier to identify now the amplitude. Let's say now the distance from the equilibrium to the peak there is 3 meters. So this means the amplitude of this wave is 3 meters, because the amplitude is just the distance from the equilibrium to the maximum, or from the equilibrium to the minimum. So that means also the distance here will have to be 3 meters. So that is all we need to understand in this video. And the part that is very much important is the wavelength, the period, and then also the amplitude. So in the next video, we are going to try and do some calculations to understand wavelengths. Thank you very much.